Hi, and welcome back to the Implementing and Administering Cisco Solutions, the CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we are going to briefly discuss how routers determine on making their forwarding decisions whenever they receive a packet. So let's dive on in. The thing about Cisco routers is they do not forward traffic by default. So you can buy a brand new Cisco router, plug on some devices to it, and it will not forward traffic. Now, for the Cisco routers to forward traffic, it uses one of two methods. It could either use static routing or it could use dynamic routing. Static routing is simply where you as a network administrator or the network engineer manually configure routes into the routing table, and these are known as static routes. Static routes are routes that do not change, so if there's any sort of network change, the router will not update its routing table. So with dynamic routing protocol, it's kind of the opposite. With dynamic routing protocol, the router can automatically discover remote networks. It will maintain up-to-date routing information and keep an updated routing table. Dynamic routing protocols simply chooses the best path to a destination network. So this means that if you insert a static route to a particular destination network, that path may not be the best suited path, but with a dynamic routing protocol, the algorithm within the protocol will choose the best path and install the best path within the routing table. Furthermore, with dynamic routing protocols, they have the ability to find new best path if a current path is no longer available. So let's take a look at this topology. We have PC1 and there's a server across on this side. And at both ends we have routers and we have 4 different paths. But the main question is which path, let's say PC1 wants to send this message across to the server. Which of these paths will router A choose? Will it be path A, path B, path C, or even path D? Well, to put simply, let's imagine that you, as a network administrator or network engineer, you implement a static route that tells the router to only choose path A, as long as this message has a destination to go to this server across here. Well, as long as it's a static route, the router will always choose that path as long as the router is up and it can move traffic. So if we use dynamic routing protocol, how will the dynamic routing protocol choose the best path? Well, each dynamic routing protocol has a special value called administrative distance. The administrative distance of each routing protocol simply defines the trustworthiness of a path. Well, I wouldn't say a path, but the trustworthiness of a dynamic routing protocol. So lower the administrative distance simply mean the better or more trustworthy a particular routing protocol is. So let's imagine we have routing protocol X, Y, and Z. Well, which of these paths will router A choose to send the traffic across to router B? Well, let's imagine that router X has an administrative distance of, let's say, 20. Y has an administrative distance of, let's say, 21. And Z has an administrative distance of, let's say, 19. Well, it is always the path with the lowest administrative distance. So therefore, it will choose Z because Z has 19. But there's a little catch to this. If you are using static routing or static routes within this network, static routes always have a default administrative distance of 1. So because you as a network administrator implement a static route to take path A, because of that static route, the administrative distance here is 1. So router A will always choose a static route over any other dynamic routing protocol, simply because static routes has a default administrative distance here of 1. When it comes to dynamic routing protocol, we have 2 categories. There's interior gateway routing protocols And interior gateway protocols are used internally within an organization. Then there's external gateway protocols. External gateway protocols are used on the internet. So when it comes down to external gateway protocols, there's a path vector protocol known as BGP, Border Gateway Protocol. Border Gateway Protocol is a protocol that is used to route the internet. Yes, BGP is used to route the internet. So this means that between one internet service provider and another, they will use BGP. So let's say we have ISP 1 here, and let's say there's ISP number 2 here, and these ISPs are interconnected. So how are these ISPs exchanging routes? Well, that's where BGP comes in to help them. The thing about BGP is very, very slow. So which means to say if an update, or let's say a network goes down, BGP will not push that update immediately. It will wait for some time to pass, and after some time, if the network is still down, then BGP will update the neighbor routers. Now, probably wondering, why is BGP slow? Yes, BGP is very slow. Well, imagine that this is a routing protocol that interconnects all the ISPs around the world, internet service providers. And imagine that a network on the internet goes down and BGP happen to update, push out a wave of update immediately. And while this wave of update is pushing out to the rest of the world, the network came back up. That means another update has to go out saying that, hey, the network is now available. The thing is that whenever a router receives a routing update, it has to update its routing table. And that will cause a delay in terms of the router forwarding messages. So since BGP operates on the internet, and the internet is the largest network in the world, BGP tends to be like, hey, let's sit back a little bit and see if this network will come up. And if it doesn't come up after a while, then I will update the rest of the world. That's pretty much how BGP works. Now let's focus on interior gateway routing protocols. Well, we have two subcategories. There's link state and there's distance vector. With distance vector, it is based on path and direction. And a very old routing protocol is known as RIP. RIP, which is a routing information protocol, is very old actually. And it's not really used anymore because RIP has a maximum hop count of 15. So which means if you are using RIP within your network and between a source and destination there are more than 15 hops, RIP will not be able to forward traffic between that source and the destination. Cisco created their own version of a distance vector routing protocol, which is called it's called Interior Gateway Routing Protocol. And they made a newer version, which is called Enhanced Interior Gateway Routing Protocol. This is better known as EIGRP. EIGRP was a Cisco proprietary protocol up until 2013. Now, previously we sort of mentioned about administrative distance and trustworthiness. Well, the default administrative distance for RIP is actually 120. EIGRP uses 90. Now, let's move on to OSPF, which is a link state routing protocol. So link state simply means that the routing protocol uses the cumulative bandwidth between source and destination. So to put simply, it is how quickly, or I won't say how quickly, but the fastest path between point A to point B. OSPF, Open Shortest Path First, has been a very, very popular protocol that's commonly implemented on many modern day networks. OSPF, Open Shortest Path First, uses an administrative distance of 110. Don't worry, you will learn more about OSPF later down in this same domain. There's another routing protocol known as ISIS, which stands for Intermediate State to Intermediate State. This technology is most commonly found within service provider networks. So let's imagine a router accepts a packet that has a destination address of 172.16.0.10. But within the routing table of the router, there are three possible routes. There's route 1, route 2, route 3. And looking carefully, how do we determine which of these routes will the router choose? Will it be 1, 2, or even 3? Well, what the router will do is it will look at the bits. So we would see the decimal notation, which is this one here, but the router will actually look at the bits here and try to get a very close possible match to all the bits found within the destination IP. So looking at Route 1 only has the first, let's say 8, 9, 10, 11, 12, the first 12 bits. Well, the router will also check another route to see how many bits match. This one has 16, 17, 18 bits that are matching, but the third route actually has, this is 24, 25, 26 bits in total matching. So therefore, route 3 will be the possible route the router will choose to forward this message to. Simply because route 3 has the closest possible match to the destination IP address found within this incoming packet. In this video, we took a look at discovering the difference between static and dynamic routing. You have also learned how a router makes its forwarding decision based on the routes found within a routing table. In the next video, we'll actually take a deeper dive into understanding static routing. I hope this video has been informative for you, and I hope to see you in the next one.